Like I said in the last video, there are three ways to calculate delta H. One is Hess's law, the manipulation of the equations, whatever you want to call it. This is Hess's law in mathematical method. So what does all this stuff mean? Well, delta H is enthalpy. That circle right there means standard conditions. Don't worry about it right now. It's not a big deal. I wouldn't give you non-standard conditions. And Rxn is for the reaction. So how do you find delta H of a reaction under normal standard conditions? Well, you have this big old ugly thing, and it looks intimidating, but it's really not. This sigma means the sum of. That N is for you to not pull a Kelton. Remember moles. Show you in a minute. I always forget that, okay? But you find the delta H value, and F is a formation, for each product, and you multiply it by the number of moles of that product. And you add all those up. Then you subtract the sum of all the delta H values for the reactants times their moles as well. It really is quite simple. So here's an equation. SiCl4 liquid. This is really important. I know normally I don't write these down. You absolutely have to pay attention to the details now. Two waters that are liquid, SiO2 that is solid, and HCl that is a gas. So you look these up in an appendix or in a data table. I pulled these out of the back of my AP chemistry book. And these are the delta H values for each one of these. So SiCl4 liquid has a delta H value of that. Water that is liquid, why do I keep emphasizing that? Because it's not the same for gas and solid, is this value, and that's that value, and that's that value, okay? So how do you do this? It's the sum of the products. So you start with the product side. So you look up SiO2 and you get negative 910.9. Notice the coefficient is 1. So you're going to have 1 times negative 910.9. Do you have to write the 1? No, of course not. I'm just showing you that. Don't forget the N. I always do. Always, okay? And I looked up HCl gas, and that's its value, but there's 4 of them. So 4, and then negative 92.3, okay? So those are all of my products. And then I'm going to subtract the sum of the reactants. Well, there's one of these, 1 times negative 640.1 plus 2 of these, that's its value. And I'm running out of room, I apologize, 285.83, okay? And then I like to simplify as I go. Otherwise, if I try to do it all at one time, I mess it up. So I'm going to simplify over here, and then this is going to be minus, I've already done the work ahead of time, you guys, 369.20, I'm assuming. Man, my handwriting is awful. Whew, you should be looking at my notes, you guys. And then this is going to be negative 640.1 plus another negative 571.66. So honestly, the hardest part about all of this is all the stupid negative values, right? So when you add these two up, because you have a negative and a negative, you just add them up, you get negative 1280.1 minus. When you add these up, you get a negative 1211.76. Well, of course, this is going to change the sign. So negative 1280.1 plus 1211.76. And grab your calculator and you get negative 68.3 kilojoules per mole. And how do I know that's the answer? I mean, besides the fact that I have an answer key and I looked it up, this value goes to the tens, hundredths, tenths, hundredths. So our answer is going to go to the tenths. And there you have it. And don't forget, when delta H is negative, it is exothermic. And that is how you find delta H, doing it the math way. Really isn't bad as long as you remember to multiply by the coefficients. Go practice.